We have now defined the circular functions, and what we're going to do now is study them as functions and look at their domain and range, in particular of the sine function, and you'll look at the other circular functions on the activities. So first of all, we're going to explore any possible restrictions on the inputs of the sine function. We've already extended those to numbers past 90 degrees. Let's see how far we can stretch them. Then we're going to use the unit circle to determine the range of the sine function. Okay, so here's our function, f of t equals sine t, where t is in radians, and I'm using t as my input variable because x and y is what we use for the x and y coordinates of the circle. So let's see what appropriate input values we have for our function. Here's our unit circle. We're just going to stick with the unit circle for right now. And again, notice the x-axis and y-axis. Those are, whenever we talk about x or y, that's what we're talking about. Whenever we talk about t, that's always the input to our sine function. So we already know how to define sine t and cosine t on the unit circle, and that is the cosine t is the x-coordinate, the sine t is the y-coordinate. I've actually labeled those without the right triangle this time, not because I can't draw the right triangle. If you want to draw the right triangle, you can, but because our official definition using the unit circle is cosine of t is the x-coordinate on the unit circle, sine of t is the y-coordinate on the unit circle. All right, and guess what? Sine of t is right there as the y-coordinate, so if we want to know about sine of t, we just have to know what the y-coordinate on the circle is going to be. So we already know we can have values of t bigger than pi over 2, right? Because we go over pi over 2, something like this, and it still has a y-coordinate, we still get a sine of t. And we can certainly do all this all the way to 2 pi. We can go all the way around. There we get a sine of 2 pi equals 0. And the question is, can we go past 2 pi? And what does it even mean to go past 2 pi? Well, let's do an example just to show you how. It turns out we can go past 2 pi. And let's do one that's just a little bit past 2 pi, 11 pi over 5. And if you can't see how that's past 2 pi, 2 is the same as 10 over 5, right? 10 divided by 5 is 2. So 2 pi is the same as 10 pi over 5, and 11 pi over 5 is a little bit more than that. So there's our 2 pi. 11 pi over 5 is just a little bit more than that. And so what we do is we go around the circle all the way around once, and then additionally that extra angle to get to, again, to a point on the circle. And guess what? We still have a y-coordinate and x-coordinate. It's still totally appropriate to put 11 pi over 5 into sine of t. What about negative values, right? So we know that we can go past pi over 2. We didn't ask about going past 0, did we? So what if I had something like negative 3 pi over 8? Well, if you think about what the positive angles do, is you start on the positive x-axis and you go counterclockwise around that angle. It makes sense that a negative angle would be the exact same angle, except this time you're going counterclockwise. Or, I'm sorry, going clockwise, excuse me. So you're doing that, right? So you start at the positive x-axis, you go clockwise 3 pi over 8 radians, and that gives you the angle negative 3 pi over 8. And so even if you had something crazy like negative 13 pi over 6, you can actually compute the sine. I'll show you how to compute the sine on this one. It's not really important. It's not 100% important how you compute this, although it will be helpful later. But what's really important is that we actually can compute a weird value like negative 13 pi over 6 for sine, and it doesn't cause any sort of problems. So there is negative 13 pi over 6. Now it's a little bit beyond negative 2 pi. So it's negative 2 pi and a little further negative, because 2 pi is 12 pi over 6, and 13 pi over 6 is just another pi over 6 past that. So negative 12 pi over 6 is going clockwise once, one revolution, and then negative 13 pi over 6 is going just another pi over 6 radians in the clockwise direction. Which means the angle that you get just looking at that angle with the x-axis is pi over 6. And if you want to set up the right triangle for pi over 6, again, the convenient one that I like to use is a radius of 2. The opposite side is going to be negative 1, and the adjacent side is going to be square root of 3. Which means sine of negative 13 pi over 6 would be opposite over hypotenuse, negative 1 over 2. And notice that you can compute cosine of negative 13 pi over 6 in this way as well. You'll be exploring that in the in-class activities. All right, so yeah, so you get negative 1/2. I like to simplify things, I guess. So what that tells us is that any number that you can imagine, you can put it into sine as an angle in radians, and you can get an output for sine. There's no number that you're going to put in that sine does not know what to do with it. What you'll do is you choose your number, whatever number you want, whatever real number you want, you put it in there. Sine will go either clockwise or counterclockwise, the appropriate angle, and wherever it ends up, that's the x and y coordinate that gives you your cosine and your sine. All right, so now that we've sort of discussed the domain of the sine function being all real numbers, let's go ahead and look at the range. So again, the definition of sine t is you make the angle t, and then cosine of t is the x-coordinate, sine of t is the y-coordinate. And again, our outputs of our function are going to be the y-coordinates of the unit circle. So if I'm looking for the range, I want to know what those y-coordinates can be. And what I'm first going to do is figure out what the biggest my y-coordinate can possibly be and what the smallest my y-coordinate can possibly be. Well, let's see. If I want what the biggest it can be, the highest I can go on that unit circle, the most vertically high point I can get is right there at the top of the circle. Y-coordinates don't go any further than that, and that is at y equals 1 because it's a unit circle. So 1 is the biggest, and then if you want to see what's the most negative, that's going to be the lowest point on that circle, way down here. That's going to be y equals negative 1. So and as you go between those 2 points, you can get any value in between. So the range of sine is going to be the set of all real numbers between negative 1 and 1. Now what I'm going to have you do in the in-class activities, I'm not going to do it here. I'm going to let you figure it out. Try the same analysis on the cosine function, and you have to keep in mind that it's going to be very similar to the sine function, except now you're looking at outputs being the x-coordinates of the unit circle. All right, and those in-class activities can be found on domain and range of circular functions.